introduce our next speakers. Peter Lund. Prior to his current role, Peter worked at the University of Canterbury, New Zealand, developing research support services and managing the library's academic liaison teams in the aftermath of the Christchurch earthquakes. And Martin Lucas-Smith is a website developer. Hi, Martin. With particular interests in low maintenance information architecture development. His work includes development of online web applications and the construction and maintenance of websites. And the title of their paper is, Have You Searched the Library Catalog? Migrating Catalog Records from Pre-Internet Software to a Modern Library Management System Supporting Mark 21. And after their session, we will go into the breakout session for half an hour, so please stick around for that. And with that, I will mute myself and turn it over to Peter and Martin. Thanks very much, guys.
Okay, sorry about that. Can you see the screen now?
Yes, it looks great. Thank you.
Okay. Well, apologies for the delay. My name's Peter Lund. I'm the librarian at the Scott Polar Research Institute. Our library is a highly specialised library, which is part of the University of Cambridge. We support the Institute's 30 or so postgraduates, as well as academic staff and postdoctoral students. We have other users, including researchers and students from other departments, notably geography and the social science subjects. We also support the Polar Museum and the researchers there. And we have scholars, visiting scholars who come from all around the world to study with us. So although they're not large in number, some of them come on sabbatical and stay with us for up to 6 months. So we're quite an unusual library, and we also welcome members of the public interested in researching the polar regions or glaciology. As the Institute's librarian, my answer to most subject inquiries tends to start with, have you searched the library catalogue? Just like the phrase, have you tried turning it off and on again, that we've all heard on the IT crowd, it's almost a mantra. But our library catalogue has not been easy to use, and until recently, it was only available in the library itself. So asking users to search for themselves was quite a hard sell. And until we migrated our electronic catalogue to Alma in October 2019, our catalogue was held in Muscat, which is a museum-based or museum catalogue system dating from 1985. So well before Tim Berners-Lee came up with the World Wide Web. And with users increasingly growing up with web-based services, our Muscat catalogue was very, very out of date and no longer supported by the organisation who had provided it. So clearly it was time to change. And our aim was to migrate the catalogue into the catalogue used by most of the University of Cambridge. And at the start of this project, it was Voyager. But in around 2017, the university moved to Alma. So for us, the goalposts moved. There are around 116 libraries within the University of Cambridge, and these include the main university library, 21 affiliated libraries, a range of faculty libraries and so on. And nearly all of them use the ExLibris products, Alma for cataloguing and Primo, which acts as the discovery tool. So we sought out to migrate our catalogue to be part of this shared library. And we were hoping that this greater visibility would increase the use of our library, improve the quality of our cataloguing records by conforming to Mark 21, RDA and AACR2 standards, and enable library staff to benefit from copy cataloguing. Also, it's fair to say we didn't want to be the last library in Cambridge to migrate. We also wanted to make sure that our readers would be able to see our library catalogue from almost anywhere in the world, wherever there was an internet connection. And for us, that could mean the library in Tromsø in the Arctic. It could also mean a range of places in the Antarctic. Our catalogue contains around 50,000 monographs in 90 languages, including Russian, Inuktitut, and Sámi, and that adds to the complexity of the migration project. Our collections about the Russian North, many of which are in the Russian language, are particularly strong. Our catalogue also contained analytic records for over 100,000 journal articles and book chapters, a legacy from when we produced an abstracting journal called Polar and Glaciological Abstracts. The Polar Library uses Polar UDC to index catalogue records. This classification scheme is derived from the Universal Decimal Classification, but it has additional sections for the polar regions. And our catalogue records have very deep subject indexing, and we were very keen to maintain this level of metadata in the migration process. Before I hand over to Martin to explain some of the complexities, just talk a little bit about the impact that the success of this project has brought. It has meant that our catalogue is now accessible from almost anywhere. It has increased visits to the library by first-time users, and indeed this impact was nearly instantaneous. The day that we migrated, an English language student showed up in our library asking for a specific title that she'd just discovered on iDiscover, which is what we call our Primo discovery tool. And since then, we've seen an increase in use of the library by geography students and an increase in interlibrary loan requests too. Though it has to be said that with COVID-19, our library is currently closed, and so we're not getting too many visits right now. In terms of further developments, having our catalogue records in Alma has meant that we've more easily been able to collaborate with the University Library in transferring low-use serials to the university's off-site store in Ely, Cambridgeshire. And particularly the creation of holdings and item records in Alma has ensured the location of these holdings could be changed quickly and easily. And while that project has been put on hold during lockdown, we have been busy this summer creating reading lists for our geography undergraduates and master's students using Leganto, which is an added module to Alma. And this has been a godsend for us in terms of being able to provide clickable links to records in iDiscover and links to the full text of articles and ebooks, which in the COVID era has been absolutely vital. A large number of people worked on this project over a significant period of time. So really this is just a name check to all of the people that have been involved, both in the Scott Polar Research Institute and the University Library, helping with the mapping of fields, with data cleaning and sandbox testing. So thank you to everyone, and particularly to Martin Lucas-Smith, to whom I'll hand over now to explain some of the complexities of this project.
So Peter, can you unshare your screen?
Thank you. Okay, I've unshared.
Hello everyone, I hope you can hear me okay. Perhaps Peter, you could just put your thumbs up just to confirm that. Great. Yes, I'm Martin Lucas-Smith, and I'm a web developer based in geography. I knew nothing at all about MARC or library science really at all before I started on this project. But basically, the problem we had is, as Peter said, we had basically a very old system using Muscat, which is essentially a piece of 1980s technology that was actually written in Cambridge. It was actually heavily used on the internet for searching in the mid-90s. And we have basically 204,000 records, which represent roughly 100 person years of work. So I was extremely, I was very much aware of the weight of history on my shoulders to make sure that the conversion work, which I undertook at programming level, was accurate. The picture here shows, I mean, the era of this is from the sort of Commodore PET era, although we don't have such machines here, but you can see on the screen a record that we had. So it's essentially just a text file. on the left, and it's sort of key value pairs. So on the left, you have sort of indicators. So star A meant author, and on the right-hand side, you have the value. And you can see there are sort of various idiosyncrasies. So you can see there that an umlaut in the third line, O umlaut is O top hat U, and so on. And this is pre-Unicode. So we had basically the Latin character set, which was quite challenging given that we have a lot of Russian records. There's almost no validation, certainly no authority control, and essentially represents really a bygone era. Basically, I as a programmer, my approach is always to produce sort of scripts that can be reproduced and rerun and iterated until it improves. And so the main way in which we worked is we had the original data, and I wrote a long script which basically converts it in the course of about 6 to 12 hours overnight. And the work was very much a mixture of writing code. Obviously, there's a huge part of it, but also there's a large amount of fixing of records. So it was a highly iterative process. So often I would write some code which sort of translates the old Muscat record into the MARC record. In the process, we would find problems in the MARC records, and then that would the library volunteers and others and staff would work to improve the underlying record themselves. Overall, I think I spent about 200 days of coding work over a period of 7 years. It was a very long-term project, and it was very much work that was slipped in alongside many other projects that I was working on. So the screenshot here shows you a picture of the system we created. It's a sort of fully interactive website, which meant it was very quick for me to sort of develop and work on. Just to give you a sort of overview of how we converted it, because it was a very long and detailed process. The first thing we did was actually to get the data out of Muscat and into essentially a text file, which I then worked to convert into a database. And that meant we had about 9 million individual lines of data. So, you know, the forename of an author is one line, the surname of an author, and so on, the title, every part of it. And you can see on the screen here an example record now converted. So here is the original sort of format. And you can see here we've sort of split it up into individual lines, and it's now sort of indexed by the type of information. So the record number Q0, A for author, and so on. And so, yes, we had about 9 million lines of data, which is about 40 per record. And you can see they're relatively detailed records. The next thing we did was to interpret the structure of the records, because what we started with is just a sort of list of key value pairs in a sort of implied order, but that doesn't actually contain a structure as such. We used a Xpath, which is an XML-based language, which basically sort of we were sort of dropping the record into a structure. So if you imagine we sort of have holes in which any particular thing can go in, like an author, and we sort of dropped it in, and it sort of finds the right hole, we then get a sort of hierarchical record. So you can see here, just about on the second row, the N1, which means the forename of the author. That's within an article group, an author group, an author, and then the N1. So it's like a hole in which that particular kind of data can go into. There's also a lot of work to convert all kinds of proprietary stuff. So, for example, umlauts, as I say, so A top hat U becomes an A umlaut, and you can see there we end up essentially with now sort of proper Unicode characters. So once we've now got this data, we actually now were able to turn it into a kind of a hierarchical structure. And this was very important, because things like if we need to know which author number, so for example, the fourth author, we couldn't do that when it was just a list from top to bottom. We actually needed to be able to say, find the author and then go into the fourth item. So the other element of this is also that we could determine parent-child relationships. So a big part of the catalogue, as Peter said, is that we have a large amount of analytic records. So items within journals and also items within books, which cause particular problems. And that means that the journal had a record of its own, but that each article within the journal also had a record. And so you have this kind of idea of parent-child relationships. Now, this is a 1980s system. It's not a sort of modern database system which would use a referential integrity, as it's called in database terms. The only thing that we could do is match on the name. So you can see here, this is a sort of hierarchical record. We have the particular title of the article, and it's within a star J, a journal, which has the title. And so there's the title of the journal. And one of the problems, of course, was that if someone changed the name of the journal in the main record, for example, putting a dot at the end or something, all these records would break. So there was a lot of work to kind of match things up. There was a lot of work sort of using some sort of language-based searching to see, to sort of find likely candidates, so we could sort of try and get the data more consistent. So yeah, so at this point we had this sort of hierarchical record which we could then manipulate. So the fourth stage, which really was sort of kicking off the real work, was to sort of do basic mappings of Muscat, the original record, to MARC for each field. So here, for example, we have the classification, the UDC classification, which obviously would map to a 650 or 651. So originally we had these sort of K pairs, each which contains a KS, which is the number, and the KW, the keyword. And so you can hopefully just about see on the screen that this K with a KS and KW becomes a 650 with the value there. So we've got the $A and the $2. And so a bit of programming work to kind of sort of put things, sort of match things up and put sort of construct the string together. And so soon we have very basic sort of MARC records. But of course, in practice, library data is a lot more complicated than these very relatively simple things like 650, sorry. What we did then is I extended this principle and created what I called macros for each sort of conversion. So in the case of an abstract, we know this goes into a 520 $3. So what I wrote is a sort of template that basically says we have a 520. There's a three hash for the indicators and a $A, and you can see here there's a sort of placeholder which says that basically put the abstract. So find the abstract. And then we can pass it through various things, like, for example, putting a dot at the end if there's not one already. And so we take this original data, we pass it through this macro, and it sort of fills that in, and the result is we get this result at the bottom. And the macros become sort of more and more complicated. So this is a relatively simple one, but if we're, for example, talking about authors, which we have to deal with all kinds of issues like the related terms, transliteration, and so on, that can all be dealt with through these macros. And so what we ended up with is this massive list of macros that basically maps all of the MARC fields and their indicators, of course, to from where they originally come from. So, for example, if we look at let's have a look. For example, a 490 comes from the TS field and so on. So really, and each of these macros is sort of complex programming language that takes the Muscat data and maps it into the MARC data. This is a quick example of the code. So the leader, for example, it's very sort of detailed things. We had to look at the form of the record. And so, for example, insert resource or microfiche and so on, that gives you for position 6 and A, for a map position E and position 6 we get an E and so on. And so, large amounts of really detailed, really quite backbreaking, sort of mind-breaking work, as it were. So really quite complex logic for each of the macros. And these are available, the whole work is available online if anyone wants to sort of look into this in more detail, if you're that interested. And so eventually we end up with a full MARC record. This is sort of completely generated live. Which meant that, for example, so here's the original data, it meant that if I changed the programming language and I pressed refresh, it would then show the changes. So it made it a lot easier to sort of iterate very quickly, to sort of see the record as it was, and for others to look at it and comment and so on. So let's go to that. In particular, there was a lot of iteration with the OPAC. The general approach that we took was that we tried to stick as far, we always started from the MARC record, from the MARC specification. Which I have to say as a program is not what I'd call the most high quality specification, but nonetheless, it is reasonably good documentation that we work from. So the aim was to get to that, and then to see if the OPAC itself needed any adjustment. So, for example, we found that 505 fields with the contents list wasn't actually showing, and we had to ask the people running the OPAC at the University Library to switch that feature on in Alma, in iDiscover rather. But a big part of this, getting this MARC records correct, was testing. And so I wrote a full-scale testing suite, and there are over 1,000 tests that were created. If I just so you can see, if I just scroll down this page, many tests. And what these tests do is they test every specific part of the conversion. So, for example, if we look at this here, we see the original record has some conference data. It's from a conference, and so we said that basically in this record, number 57464, we expect that in the mark line 111, and we expect the result to be this, and on the right hand side is the actual result that's created as a result of the conversion work. And what this meant is that as time went on and as complex changes were continually made, I could see whether things broke. And this was a really critical thing. And for the first few years, we didn't actually have this. And it was very clear to me that really we desperately needed a testing suite. And so, as I say, there are over 1,000 tests. We got to only 4 failures, which I was very pleased at. But these are really very detailed tests. Everything down from making sure there's a dot at the end, except if there was a quote or something like that. Making sure that spaces are correct, making sure that large amounts of very detailed conversion were all correct. Just checking the time. And every single conversion feature had this test. And sometimes the tests were negative to make sure that something didn't happen. So, for example, if we had a 505 which had a contents list, we didn't want that to appear also as a 500. So we had to do with some negative tests as well. Just checking time. So there were just under 205,000 records. And so this was an automated process that essentially we sort of imported the data. So there's a box where the librarians could upload the Muscat data as of that day. And then basically we press the button and overnight it runs it. And then at the end, we essentially have a catalogue that can be exported to the University Library, Alma system. So there's several other things we did. So as well as the tests at the record level, we also had a program called BibCheck, which was developed locally, I think, in the university. And what it does also is check that the record sort of adheres to a whole pile of sort of relatively basic mark things. But it meant that we had a reasonable degree of assurance that the data that we were sending to the university library for them just to finally import in one go had a degree of correctness. Just checking the time. The other thing also is that we use MarkEdit to do the final conversion of the sort of text that you saw of the record into the .mrc format, which is what Alma and so on use. We didn't use MarkEdit at all in terms of a desktop program at all throughout the project. It just wasn't useful for that. All the conversion was done through this programming-based method. But MarkEdit very helpfully does have the ability to convert a file to the MRC format non-interactively. So I just want to focus on a few quick things that we particularly ran into problems with, because there were several areas of real complexity that were many times the kind of complexity I've had to do with any other project. The first thing was authors. As I say, we had just a list of sort of key value pairs which had the authors broken down. But of course, authors have complexity. We have things like obviously how many authors there are. They have to be split between the 1xx fields and 7xx. We also had to generate 245 fields. So essentially by joining the title / authors, and obviously they're in different formats. So we had a flow chart that basically takes the author details and sort of works out what goes where and how it gets munged around to generate both the 1xx and 7xx and the emulated statement of responsibility. And there are all kinds of things. So, for example, that when there's a second author, it sort of mutates from being a 1xx to a 7xx. We had things like spotting when it's a conference based on a list of keywords. We had to do with related terms and so on. We also had to do with 880 handling because the Russian stuff was a big element. And in the last few minutes, I'll just talk about the Russian side of things. So the authors was a big and complex area, but we have a spreadsheet which you can even download and have a look at what we had to go through. Analytics was a big problem, a big area.
I just have just 3 minutes left in the session.
Yeah, that's
so,
yeah, I can see that. That's great. Yeah, I've got a time thing here. So the analytics, we had many huge problems with these because of the way essentially the original records were not. They're just essentially every book or record is a single thing containing both the details and the instance of the book or whatever. And so we had records sometimes that represented individual item records as well as items within a journal. And so there's extensive logic to sort of split these out, to deal with pamphlets within books and within binders and so on. And also to get the names aligned with the university library so that when the journals could go in, that actually there was matching up of the journals. The last massive area of work was dealing with Russian transliteration. This is a hugely complicated area. We had no Russian text within the catalogue. As I say, there was it's purely US ASCII. But by the end of the project, we had generated automatically through the import overnight. It generates 140,000 completely fresh Cyrillic strings. So we did have transliterations, but unfortunately, the transliteration used the 1947 scheme, which is not reversible. And so what we have on the left here is the record language. So these are Russian, or sometimes Russian and French if it's a parallel title. And so the left shows the original text. You can see the transliteration, the 1947 transliteration. And so this basically gets converted to real Cyrillic. So you can see here examples. I had to create a spell checking system. We had a system whereby you could thumbs up for when it's a name. We also checked Google to find whether names and so on were real names. Also to do with parallel titles. So you can see here that we've got the first half is in Russian and the second half is in French. And then we had to convert that into the so that became the 880. But then we had to convert that back into Library of Congress. So it had gone from this old transliteration into Cyrillic and then into Library of Congress. And so there's a huge problems, italics and all ship names and so on had to be dealt with. So just very, very final slide. Last thing is we did reports, which basically checked the records at the end and found issues, which meant that the librarians could sort of work through these records. It essentially found a lot of the legacy problems within the data. And so the data was finalized last year, sent to the University Library. We're planning a journal article about the project. The code is open source on GitHub, and we're going to give it a DOI soon. And there's documentation which we can look at that deals, for example, with how we dealt with transliteration, which, as you can see here with documentation, was a very complicated process. And there's basically ongoing long-term work now to fix up the data. So thank you very much.
Okay, thank you so much. Unfortunately, we don't have any time for questions, but hopefully you can go into the breakout sessions and ask questions there. I've had just a couple of housekeeping things related to your presentation. If you could put the link to the GitHub site into the chat so that people could see it. Yeah. And as well as the people asking for your presentation later, and we will be posting the slides later on at some point, as well as the recordings of the presentations. So from that, thanks very much. I'm going to put people into breakout rooms now. I'm going to make 4 rooms that will be automatically assigned. If you are not able to use a microphone or anything like that, that's great.